Okay, so the three different types of fats, you said phospholipids, fatty acids, and steroids. Do you know the differences between the three?
Well, triglycerides have the three fatty acids and then glycerol. Glycerol.
Mm-hmm.
And then phospholipids have two fatty acids, glycerol, and either nitrogen or phosphorus on it.
Yeah, that's a basic idea. And did you say steroids?
Steroids, I'm not as clear on.
So steroids, they typically don't have you do the structure of it, like what it's composed of, because they're a little more difficult. But steroids, they come from cholesterol. So you get cholesterol, and then through different enzymes or whatnot, it can be converted into different steroids. Simple answer, dextrose is basically glucose, okay? The difference is that glucose has transporters to put it through the cell. So you have your cell right here. There's little channels for glucose to be pumped in or could technically be out, but dextrose, there's not.
Dextrose has no.
Dextrose doesn't have channels or transporters for it. Where that gets important is, have you talked about like osmolality and
Yeah.
have you talked about tonicity, like
No.
if something's tonic or not tonic?
No.
Okay, that it gets important, which that'll probably be in the next section. Is basically that the dextrose isn't going to be able to go through the cell.
Okay.
That's why it's important.
Okay. How are triglycerides and phospholipids similar and different?
Okay. Answer what you can for me, and then I'll fill in any cracks, because I think what you told me, you know a bit of it.
Consists of like fatty acids and glycerol.
Okay.
Phospholipids sometimes have the nitrogen and the phosphate along with them.
Mm-hmm.
I think both.
They're always going to have a phosphate, and I think they always have the nitrogen as well.
That's what it sounded like.
But yeah,
sure.
because if you think about the word phospholipid, phospho comes from phosphate, and then lipid is talking about the two chains.
Mm.
But yeah, so the 2 chains versus the 3 chains, triglyceride versus the phospholipid has 2. So the glycerol, triglyceride, phospholipid.
And those 2 chains are from the fatty acids, right?
Yeah, they're fatty acids. Yeah. So, real quick question: polar things and non-polar things. Do you know if the fatty acids are polar or non-polar? Let's go back to the chemistry section.
I think that the head is, but the tail, the fatty acids aren't.
So you're on a good track. Okay. So these are non-polar. Non-polar. For the glycerol is non-polar.
Okay.
Okay. But this guy has a polar head and non-polar tails. Do you know how things that are polar and non-polar interact with water?
The non-polar, the water just goes around the polar. I'm going to try to describe it.
It interacts with it. It's kind of like, so I'm going to erase this for a second. I'm going to do a 2-second chemistry review. Is that all right?
Yeah.
Okay. Okay, so here's a water molecule. Oxygen to hydrogen. Okay. So these are polar bonds. Do you know what polar bonds are versus non-polar?
Yeah, polar. I think it's like one side of the molecule is negative, one's positive.
Okay.
And
That's a great start, because so polar, you think of magnets, and that's kind of how it works. Okay. So we've got a negative end here, positive end on this side. So like a magnet, things that are also polar, like magnets, are going to interact well with these. They're going to dissolve. So if I give you a little bit of sodium chloride or salt, table salt, put it into water, it dissolves, right?
Yeah.
So sodium chloride, that was an ionic bond that I just named. But so because one end is positive, it's going to be attracted over here. One end's negative, it's going to be attracted over here, and it dissolves quite nicely in water because it's a polar solvent. Okay, so imagine you have your magnetized water, if you will, but you try to interact it with something like wood. It's not going to interact very well. The wood's not going to dissolve in the water because it's not polar.
Yeah.
I just felt a bit nerd. But yeah, so it's non-polar, so there's not a real good interaction going on in there. But when you find something that's polar or ionically bonded, so they're charged, then it's going to dissolve. So if a fatty acid, so triglyceride, is non-polar, is it going to dissolve in water?
No, it's not.
So that's why when you take a drop of oil, it drops in, but then it tries to float to the top and kind of stays separate from the water.
Okay.
So that's why it works, because these tails are made of all these carbons and hydrogens,